Hello everyone. Today I'm dealing with the topic access function and utime function. Access. The access function checks the existence and or it might be only one access permission. So that means of a user to a named file. If any user or a process wants to access a file, whether the file is created or not, whether it is existing or not. So it will check the existence. It will check the existence as well as access permission. What all the access permission it has, whether it has a read permission, write permission, or execute permission. So before we operate, so it's better we can check all the file permissions and then go ahead and operate on the file. Either I can do both, check both, or I can check any one of this. The syntax or a prototype for access function is hash include UNISTD, int access, constant path name, and the flag. All these modes, read-write modes, are defined in the access unistd.h function, and the access function is also defined in unistd.h. And path name is nothing but the file path name, the complete path name. It's an absolute path name or a relative path name. And we have a second argument of an int flag. Let's see what is int flag is. The flag contains one or more bit flags. It contains one or more bit flags, which is actually defined in all those bit flags are actually defined in unistd.h header. So let us see what are the bit flags. First one is f underscore OK. OK. Checks whether the file existing or not. R underscore OK checks whether the calling process has read permission. W underscore OK checks whether the calling process, who is a calling process? The process which is actually trying to access. So this is our process. So this is our process wants to access a file. So our this is our file. So this is our file. I'm very sorry. Handwriting is coming little. So this is my P is called a calling process. Who is actually calling to read the file? It's a calling process. So, and then checks whether the calling process has execute permission. So all these four options I have. So this is my existence. The first one is an existing of a file to check whether existing of a file, and other three options are access permissions. The flag argument value to an access call is composed by a bitwise ORing. What do you mean by bitwise ORing? I can use any number of this, one after the other. I can keep writing, but I should use a bitwise OR. Trying to add on everything. Let's see an example for that. So now I want to access this file. So the following statement checks whether the user has a read and write permission on a file called this. This is my file actually. Checking whether a read and write permission is there or not for this file. So now I am just checking the status of this. I'm taking the written value of the access. So giving a path name here, the first one. The second argument is my flag. I have specified two flags here. Each flag followed by a bitwise OR, followed by a second flag. Again, I can use OR followed by a third flag, and I can use all four by using by adding a bitwise OR in between. So now here for this file, I am checking both whether the file is having a read and write permission. So the function returns 0 if all the request permission is permitted. Otherwise, it is -1. So let's check an example here. Yes, let's check an example here. Just check. I'll just execute and show you this example. It's an int main. I have to specify all relevant header files, and the buffer I've taken, and I've taken a 2 variable. I'm using a while argument. That means I'm taking n number of arguments here. For each command line argument, I'm applying on all this. Okay. I can specify any number of files. Here is my access. I'm checking. Before I do the operation, I'm just checking whether the file, whatever I'm giving in a command line argument, is existing or not. So the whatever I give in a command line argument is existing or not. So what I'm checking here, if it is not existing, okay. So because what is the return value of if? Return value of is if 0, if it is successful. So if it is 0, it comes here because if of 0 is an else part. If of 1 is inside part. So if it is -1, it comes inside. That means if there is no existing of this file, then it is assumed it has a brand new file and then it will enter inside and creates this. You can check here. I am taking the same argument, what I'm reading, and then I'm making a write-only mode. With that, I'm creating. When I'm creating, I have to give the permission. 744. What is a 7? Is a owner permission, read, write, execute. All 4 I have. Read permission I have only for a group, and read permission I have for the others. So when after creating, what I will do, I will put some data into that file that saying that hello world. So that is my write data to the same file. FDEC is a return value of open function here. And I am writing how many bytes? 12 bytes. What is that I'm writing here? Directly the content I'm writing, that is a hello world. Else part, if file is existing, then what I'm doing, I'm opening that file in a read mode. I am just reading the complete file. I'm putting it in a while loop. How much is a buffer? Buffer is only 256. Okay. So if my file is too lengthy, say 1024, if I have, it takes first 256, put it in a buffer, specify here, that I will put it on the read. What is file descriptor 1? It is a standard output. File descriptor 0 is a standard input. 1 is a standard output. 2 is a standard error. So standard output, it prints on the screen. The first, again, it will go. The next 256 reads, prints. Next 256 reads, prints. This will go on till the length becomes -1. I mean, it returns an error. So that's about the while function here, if it is not existing. So that's a close argument, and we are using the closing the file here. So that's the program here. Let us check how it executes. The file name is, I've given access.c. Check here, I've just written the same file, but I'm just telling you that I've written just 56 in a buffer here, and I'm writing it to 56 just to show you all the possibilities. Fine, just remember that. Now I'll just say cc./out. I'm giving a file which is currently I'll just give which is already existing. Link.c is an existing, it is a small program. So it has more than 1000 bytes here. I'm giving one file currently, it's directly printed. So that means you just see here, it is quite huge file. But what is my buffer size I had given before? Just 56. As it was in a loop, check here. I'm reading because once it is existing, it comes here in the else part. The buffer is 56. So each time 56 writes and then writes onto the output screen. But let us check now if the file is not existing, what happens? So I'll just give a file which is not existing. Let me see some a.c, okay? Or I can say test.c, okay? Now what actually was in our gedit? Hope you remember. The edit, what I'm doing, okay, let me pull my PPT here. I'm just checking my PPT. Let me pull my PPT here. If the file is a brand new file, what is happening here? I'm opening the file, creating that file with the permissions, and I'm writing hello world there. So that means for the new file, hello world must be written, right? So first, let me check whether it is created. See, when I check LC, where is my test. Yes, it's here. Test.c is created, right? So let's say cat test.c. So hello world is placed there. So now when it is existing and not existing, both options we have checked now, right? In the access. So that's about an access with an example. Now we will go to our utime function. What does this do? The function modifies the access and modification time. So we have an access and modification time, timestamps of a file for every file. The attributes is actually stored. If you want to modify that, then I will use utime. So how do you modify that? So because this is a file's access and modification time is a file attribute. Each and every file will have the attribute. So, so if you want to change that to your own time, access and modification time, you can have this. So that is your unistd utime systypes.h and everything we have here. Systypes is for, in the structure we define the types. For that we need a 6 types. Utime is for the utime function is actually defined in utime.h, and then unistd is actually all your modification access time, modifier flags, file attributes is actually stored in unistd.h. So let's see now. The times attribute, the argument times is a structure name here I have given. The structure name is for second argument, structure name is times. The times argument specifies a new access time and modification time for a file. So this is actually defined as utime.h header. And let's see here, struct utime buffer, what all the variables is defined in the struct. So time underscore t, AC time is an access time, and modification time, both variable is defined here. Now, if you change, if your time value actually is above your 0 value, then that means you have changed your access and modification. You want to change it. Otherwise, if you make your time 0, then it is clearly telling I don't want to make any change. I just want to keep the current access and modification time. What is actually is there currently in the file, I want to keep it as it is. If I specify 0. But to do this requires a calling process have a write access permission to the open file, to whichever the file you're actually modifying this access and modification time, you need to have a access permission, then only you can do it. So that's all about a utime function. Thank you.